Um, Hi everybody, welcome to today's session on factorizing. We're going to cover quite a bit of topics today. If you do have any questions, please pop them into the chat or into the Q&A function. I'm happy to answer any questions as we go along, and hopefully you find this beneficial and useful. So today's agenda, what I've done is I've broken down everything to do with factorizing, including finding prime factors and highest common factor, and then we'll work through sort of age-wise or grade-wise, so from the lower grades, which is grade 8 and 9 for highest common factor and grouping, and then move on to these for grade 9 and 10. And then, of course, for grade 10 with the trinomials, where a is not equal to 1, and then completing the square quadratic equation for grade 11 and cubic equations for grade 12. Okay. If you are not aware, Sharpies is a maths teacher reward program. You can join the program and get points for joining us for this webinar today. And then, of course, here is the link where you can sign up. So I will send this presentation to you in PDF format on Monday as well. So you can click on any of the links that are available here. And then, of course, if you are already a Sharpie, tell your teacher friends about it and get points for doing that as well. There are some lovely resources and downloads that I always recommend. If you've attended a webinar before, you'll have seen this page. So the only new things or things that I'd like to point out is, remember, you can download the simulator link. The calculator that we're going to use today is the Sharp W535SA. So you can just download it from there. And then, of course, Maths at Sharp has got all of your worksheets. We'll be using some examples from those worksheets today. So if you want to go and practice them more or give them to your students, I've linked them for you on the pages where we've used them as well. And then coming soon is my own personal maths blog, which will also have worksheets, etc., that you can download for free. So, but I'll keep you posted about that. Cool. So the calculator today, just some very, very basic things. I'm not going to go too much in depth into it because I'm just going to use it for factorizing. So some things to note is obviously your mode button, which is over there. Your BS button in case you type in the wrong thing and you need to delete something. And then, of course, your change button if you want to change answers and equals button. The modes that we're going to be working in today is 90% of it will be in table mode for finding factor pairs when you're doing trinomials, etc., etc. And then, of course, normal mode for doing prime factorizing, highest common factor, and the quadratic equation. Cool. So the first thing that we need to look at is prime factors. And this is when we start solving, or later on when we start solving exponential equations. But it's also really nice to help us with highest common factors as well. So if you need to find the prime factors of anything, we can just type it into our calculator. So we can say 87 and equals, and then just second function and p fact, and that will break it down into the prime factors for us. Now, the other methodology that you should be able to do, and particularly from grade 8 and 9, is the ladder and the tree method. So the ladder method is simply drawing a line down your page, writing the big number on the one side, and then writing all your prime factors on the other side. So we always start with the smallest number that we can think of, which is 2. So 2 does go into 72, 36 times. Then 2 goes into 36, 18 times. Then 2 goes into 18, 9. Now 2 doesn't go into 9, so we move on to the next number that is a prime number, which is 3. 3 does go into 9, so we can just say 3, and 3 goes into 3 once. So our prime factors are here: 2 times 2 times 2 times 3 times 3. So that's basically the ladder method. You can fill in lines if you wanted to make it actually look like a ladder. The other alternative is your tree method, and that's just basically breaking it down. So 84 we can see is also divisible by 2, so I'll just start with that one because it's pretty easy. So 8 divided by 2 is 4, and 4 divided by 2 is 2. Now 42, the factors that come to my mind are 6 and 7. Sorry about that, 6 and 7. Now 7 cannot be broken down any further. It's already a prime number, but we can break down 6 into 3 and 2. So here are our prime factors, or the apples on our tree, if you will. So basically it does the same thing as this one, but just in a different methodology. So it's whatever makes you happy and comfortable with your steps, but always nice to know the 2 different ways of doing things. Now, of course, on your sharp calculator, we've actually added a highest common factor function. So if you wanted the highest common factor of 85, for example, and let's say, so we just say second function 2, GCD stands for greatest common divisor. It means the same thing as highest common factor, and 100, we can say equals, and that will give us 5. Now, what's really nice here is you can add as many numbers as you like, and it, oh, sorry, that was terribly done. I should put that in there. There we go. So you can add as many numbers as you like, and it will just keep finding the highest common factor of all those numbers. So, I mean, it's obviously not necessary to go beyond, say, 5 or 6 numbers, but you can fit as many numbers as you like, as can fit into the characters of your calculator screen, which is pretty awesome. So you have a lot of room there. Now, with highest common factors, we actually need to break down the things that we're looking for the common factors of. And often the students will struggle with these x squareds, okay? So yes, they look the same, but what if this was an x cubed, for example? So what we could do is just write it down and break it down into its simplest components. That's a times x, and that's b times x times x. And let's say it's x to the 3, then there's 3 x's. Now we can see there's no a in this one, there's no b in this one, but there's 2 x's here and 2 x's here. So I'm going to take out 2 x's on the outside, and I'm going to write down whatever I've got left. So I've just got left an a here, and it's pretend it's a plus, and a b here, and another x. So when I write it completely correctly, it's going to be x squared a plus bx. Okay. And the same again goes for the other examples as well. So for example, if we have 14 and 21, we can split them up into the factors. So we know 14 is 2 times 7 times xy, and 21 is 3 times 7. So we can see immediately that the factor that is common is 7 for the numbers. And then if we look at the letters, we can see there's no x in this one, but there are y's in both of them, so we can take out a y. And then we just write whatever's left. So we've got a 2 and an x, and a 3 and a z. Okay, and so on and so forth. So for this one again, here I can see that, well, I'm going to guess that my common factor is 5. Okay, so here I can see I've got 5 and 12. Here I've got 5 and 10. And here I've got 5 and 9. So again, my factor is going to be 5. I've got an A and an A and an A, so 1A. I've got B and B and B, so 1B. And I've got C and C and C, so 1C. So here, all I'm going to be left with is just the number because I've taken all the letters out. So I'm going to have 12. This one I'm going to have, let's just call them pluses for now, 10. And then I'm left with 1A and 1B, but no C because there was only 1C. And then, of course, here I'm left with a 9. We took out an A, we took out a B, we left with 1C. And now we are done. Cool. Trevelyn, I saw you raise your hand. Is that just to say hi, or do you have a question? If you have a question, just pop them into the chat or into the Q&A function. I'll happily answer them for you. All right, fantastic. I'm actually going to skip this practice round because we've done we've actually done these in the previous slide. So I'm not going to repeat myself again. You can sort of see what's going on. And also, it was a really long workshop yesterday, so I'm just going to leave it as is. But all of these examples come from our grade 9 worksheet 16 on algebra expressions. Okay, so for finding highest common factors. So if you want to practice that, you can just click on this link. It will take you through. Then the next thing that we need to look at is grouping. So with grouping, we need to have 4 or more terms, generally speaking. and we look for things that are common in our clumps. So what's nice here is you can see it's already sort of clumped together. You've got a plus, a minus, a plus, and a minus. That's also usually a hint either to group all your signs together. So in other words, we could have grouped them like this as well, where we had the two positives together and the two negatives together, and then you take out a negative. But anyway, we'll do the bottom version because it just makes sense. So here we can see that the two that they have in common is the c squared. So I don't know what's happened to my mouse now. Sorry, guys. C squared. So we're going to have a squared minus 2b. And then plus, and here what's common is a 3 and a d. So we're going to have left over a squared minus 2b. And we can see now, if you pretend my a actually looks like an a, that these brackets are actually the same. Okay, so then what we would do is just write the brackets down as the same. Okay, and we take whatever's left and we throw them together in the rest in a second bracket. And if we multiplied it out, we should come back to what was what we originally had as well. Cool. So another example that we can do, and we were talking about grouping it in different ways. So you can see here, we can group it with the plus signs and the minus signs, or we could group it with the two smaller ones and the two big, if that makes sense to you. One positive and one negative, one positive and one negative. So yeah. So here, if we took out a 2 and a b, we would be left with a de and a 3a, right? And then here, if we took out a minus 7, we would, in fact, if we took out a minus 14, the whole thing, and a c, we would be left with de and a plus 3a, right? So again, then your brackets are the same. So that's the first option. Alternatively, if we did the second option, then we could take out a 2. So we could have 2de, and you'll see it will come back to us in a little bit. And then what we'd have left is a b and minus 7c. Okay. And then on this side, we could take out a, sorry, I've written far too far over. We could take out a 6a, and we'd be left with a b minus 7c. So again, your brackets are the same. Now, what you should notice here is that there are actually, so this one, you actually have a common factor across all of them with 2. So that's also something else to pay attention to, is to take your highest common factor out. And you won't have these two different alternative ways of doing the question. All right, fantastic. Everyone happy so far? We can move on to difference in sums of squares and cubes. Cool, great, fantastic. So with the difference of squares, it's quite simple. Remember to always check for highest common factor first, and then to check if you have two terms, whether firstly there is a minus sign in the middle, and then secondly, whether the two terms are perfect squares. So normally the numbers would give it away, and something that as a student you should know is the perfect squares up to, say, probably about 12, 15. And then, of course, you just follow your pattern. So I've done it in two ways because I want to make it obvious that sometimes you don't always have that perfect square on you don't always have a 2. You might have a 4 or a 6 or whatever. So pay attention to your, normally the exponent on your letters is even, but when you get to more complicated matric math, sometimes they'll expect you to factorize like this, even though it's not always obvious. Okay. So here are some examples for you. So this one is actually a bracket. And if we just looked at the bracket, we can see the whole bracket is actually squared. So I can just put a k in place of my bracket. So I can have k squared minus c squared, which is obviously a difference of squares. So I would have k minus c in brackets and then k plus c. And then I can just substitute back for my k. So I can have 3a plus b minus c and then 3a plus b plus c. So I just wanted to do this example because it's quite a one that often catches students out. Then for this one, I'm sure you're going, and you know where I'm going with this one. But again, if we do the difference of squares, so this one will be 4a to the power of 4 minus 1, and then 4a to the power of 4 plus 1. So this is no longer a difference of squares, but this first bracket is actually still a difference of squares. So we need to factorize it again. So now we're going to have 2a squared minus 1, 2a squared plus 1, and then our previous bracket, which doesn't factorize, which is 4a to the power of 4 plus 1. And then we are done. Because we could difference of squares this one again, but you'd have a square root of 2, so then it starts to look untidy and it has surds. So this is as far as I would take it for this answer as well. All right, fantastic. Then of course, from difference of squares, you also get a sum or difference of cubes, okay? And so the pattern again now is you're looking for cubes around a plus or a minus sign. So again, two terms. So just be aware of this. And then of course, when you are writing this out, so the signs always used to confuse me. So what I would say is it's the same sign as my original sign in my first bracket. It's the opposite sign of my original sign, and then it's always a plus. Okay, so if I do this first one for you. So the cube root of 27 is 3 and an x. Same sign, so I have a minus. That one is 5y. Then I just square the first term in my first bracket, so that's going to be 9x squared. I multiply these two together, but now my sign is a different sign. So not a minus, but a plus. So it's going to be 15x y, and then plus, and then always a plus, 25y squared. And now I have factorized my brackets. Sometimes you might be able to factorize it as a trinomial, but generally speaking, you don't get regular roots, you'll get quadratic equation roots or irrational roots here. Okay, cool. All right. Sorry, let me just clear that. I'm not going to do the second example because it's exactly the same. But again, I do want to repeat same sign. So your brackets will have a plus, then a minus, then a plus, because you started with a plus. Okay. So just remember this rhyme. It's very, very handy for factorizing. Difference in sums of cubes. All right. Everyone happy so far? We're all good. We're feeling alive. Fantastic. Okay. So what often students struggle with is the signs in the brackets. So I want to show you a really nice way just to find firstly your factor pairs on the calculator. And we're going to use this methodology for the rest of the trinomials just because it's really easy to find your factor pairs. And it's often something that students struggle with. So we're going to go to table mode. And all we're going to do is, let's say we want the factor pairs of 36. So you type in the number you want factor pairs of, press the fraction button or divide, whatever makes you happy, and then type in an x. So basically you have 36 divided by x, okay? Now this is a hyperbola, but we're using it for our own nefarious purposes. So there you go. So all your factors are here, 1 and 36, sorry, 2 and 18, 3 and 12, 4 and 9, 5 is not a factor because it has a decimal answer, 6 and 6. So now we can see that we've gone through all of our factor pairs and we are all done. Okay. So that's finding factor pairs. So from that step, right, now we can move on to factorizing trinomials. So with a trinomial, you always start by looking at the sign behind your C, in front of your C value. In other words, in front of the constant, the number that doesn't have the letter or anything. Right. Okay, so I say that, but sometimes you might have a trinomial with a x squared plus 6xy plus 8y squared. So it's whatever the opposite of your x squared is. Okay. So we look here and we see that it is a plus sign, and a plus tells me that the signs in my brackets are exactly the same. So I'm going to have x and x, and my signs are the same, and this front sign tells me what sign to use. So I'm going to have x plus and x plus. Now, factors of 8 very quickly are 1 and 8 and 2 and 4. And because my signs are the same, I'm just going to add them together to look for my middle term. So 1 and 8 makes 9, not what I'm looking for. 2 plus 4 makes 6, so that is what I'm looking for. And I am done with my factorizing. Okay. Again, the sign at the back is a plus, which means I have the same signs, but my sign here is a minus, so I'm going to have minuses in both of them. But because it's a plus at the back, again, I'm just going to add my two terms together to find my middle term. So 1 plus 8 gives me 9. Okay, that is my middle term, so that was easy. So it's just a 1 and an 8, and we're done. Okay. Now, when the sign at the back is a minus, it means the signs in your brackets are different. So we don't start by filling in the signs. We just fill in our x's. Okay. Again, we're going to write down all of our factor pairs. Wow, sorry guys, I don't know why my mouse is misbehaving like this today, but it's really, really super wonderful. Okay, so there we go. So there's all my factor pairs, and you can just see I've rewritten these two because I know where I'm going with the story. So in this column, I'm going to make it a minus, and in this column, I'm going to make it a plus. Okay, and what we're going to do is just say minus 1 plus 8 gives me plus 7, which is not my middle term, so I leave it. Minus 2 plus 4 gives me plus 2, which is not my middle term, but it tells me that I'm on the right track and I need to switch my factors around. So I'm going to have minus 4 plus 2 gives me minus 2. That is what I'm looking for. So I can write minus 4 and plus 2, and there we go. So really nice and easy to follow and to do. All right. So from here, I just wanted to do another two examples with you just to show you finding factor pairs with a value that is higher. So instead of typing them out into the calculator with you and taking a long time, I've actually done for you all the steps. So again, just to show you again how to find those factor pairs, what you do is you type in the number you are looking for factor pairs of, press the fraction button, press the x twice, and then equals equals equals. Okay, really quick and easy, and there's all of your factor pairs. Anything with a decimal is obviously not a factor pair, so we ignore it. So here they all are for our reference, and we can see the sign at the back is a plus, which means my signs are the same. So I'm just going to have x plus and x plus, and I'm looking for something that adds up to 9. So 1 and 20 doesn't make 9. 2 and 10 makes 12. 3 is not a factor, so I can ignore it. 4 and 5 make 9. Yes, so those are my factor pairs. Because the signs are the same, it doesn't matter in which order you put the 5 and the 4 or the 4 and 5, just as a sidebar for that as well. Now, this one I did because it has the sign at the back, which is a minus. So what we would do here is we just say, okay, my x column is a minus, my answer column is plus, and I'm looking for plus 3. So minus 1 plus 18 gives me plus 17, not going to work. Minus 2 plus 9 gives me plus 7. Minus 3 plus 6 gives me plus 3. So those are my factors. So it's this one here. So again, I'm just going to write down my brackets with my x's. And I have minus 3 and plus 6. Okay. Everyone happy with trinomials? Feeling good? Because we're going to get into the more exciting ones. So when we do trinomials where the A does not equal 1, in the Departments of Education, the standard curriculum, it's only from grade 10 and upwards that you're examined. However, the IEB examines from grade 9 and upwards. So just a heads up on the difference between the two. So I've looked up several methods that I found that I thought would be helpful. They're some similar in some ways, and I think quite helpful in other ways. So, and again, pick what you think works best for you, because some students might like the story of the airplane, whereas other students might like the box method. So it's really up to you. And I think it's always good to give them an arsenal of choice. You know, something that works for me might not necessarily work for somebody else. So I think it's important to allow our students to choose, you know, it's the same as some people have red hair, some people have blonde hair, it's just what works for them. Okay, I have digressed. So what I'd like to do here is, so this is called the airplane method. And how it works is you multiply these two together. So your 4 and your 14, which I've done over here, and it gives us 56, okay? And you look for the factor pairs of 56 that add up to 26 in the middle. Now, our sign at the back is a minus. So our one column is going to be minus, and our one column is going to be a plus, okay? And what you do is for your brackets, you write down the A in both brackets and the X in both brackets. Now, some teachers don't like that because of this particular part, and we will get rid of that for later on, but they don't like that the methodology doesn't cover it or the reason for it in depth. Okay, but it is something to make your students think about why we do what we do and the reason for following the steps that we do. Okay. So we're looking for something that makes 26. So 1 and 56, nope. 2 and 28, yes. So we've got minus 2. Oh, no, wait, wrong way around. So what we actually should do is make this a plus and this a minus, then it will work. So plus 2 minus 28 gives me minus 26. So I've got plus 2 and minus 28. Okay. Now, we should have actually taken our highest common factor from here in the beginning. But anyway, I'll get to that in a second. Once we're done with that and we found our two factors that give us 56 and add it to our middle term, we're going to divide the whole thing by a 4, or the original A. And that's where the airplane comes from. So there's the wings, and the 4 is actually your wheels of the airplane. Okay. So here we're going to be left with 4x plus 2, and I'll come back to that in a sec. And here we're taking out the 4, so we're going to be left with x minus 7. Okay. So here is actually a highest common factor of 2. So we could have actually started by taking out the 2 first, and then continuing to factorize the rest of the equation. But it is up to you, and we should have actually taken it out. The highest common factor is always the first step, but it does make it for an interesting question as well. Okay, cool. Everyone happy? So that's the airplane method. What I'm going to do now is move on to the crossover method. Now, this is in fact the method that I was taught in high school, which feels every day further and further away. Okay, so what we do is we list all the factors of A. So in here, it's just 1 and 5, and then I'm just going to double it over and write 5 and 1. Okay, so normally you double over the factors that have the least number of factors, and you only need to do it with one side of them. So I normally pick the A just because it's normally smaller than the C value. Okay, and it's normally a prime number or something little. Do you know what I mean? Okay, then we list all the factors of 54. So we've got 1 and 54, 2 and 27, 3 and 8. Am I right? 54 divided by 3. Yes, I'm right. Okay, fantastic. Then 4 doesn't go into 54. 5 doesn't go. 6 goes into 54 9 times. Okay, and then I think we're all done and we found a lot of factors. Okay, so what we do is we cross, that's where the cross method comes from. We cross multiply across and we look for what adds up to 51. Now the sign at the back is a plus, so I'm just adding the two multiples together to find the middle term. So 1 and 54 gives me 54. 5 and 1 gives me 5. 5 plus 54 gives me 59, not what I'm looking for. 1 and 27 and 5 and 2 is 10, so that's 37, not what I'm looking for. 1 and 18, 5 and 3 gives me 15, also 30 something, so not what I'm looking for. 1 and 9, 5 times 6 is 30, that gives me 39, so not what I'm looking for. So in fact, this first set of factors doesn't work. Now we repeat it over again with the second set. So 5 times 54 is going to give me 270 something. So we're going to just ignore it, or 270 exactly. That doesn't work, it's too high. 5 and 27 is going to give me 100 and something. So again, that's not going to work. 5 and 18 is going to give me 80. So that's again too high. 5 and 9 is going to give me 45. And 1 and 6 is going to give me 6. And 6 plus 45 gives me 51. So I found my factors. So we group them together and then we draw our oval, which is like this. And what this tells us is that these two belong in the same bracket and these two belong in the same bracket. So we're going to do 5x, and the signs are both a minus, so minus 6, and then just x because it's 1, and minus 9. And now we've factorized it. So this one takes a bit of practice, and you need to be able to do your times tables for the crossover method. And in fact, with all of factorizing, you need to be able to add quickly, and you need to be able to do your times tables. So practice on your drill function because that will definitely help. I still practice on my drill function. I know you can't tell, but I do. Okay. Now the other option is to do the Khan Academy way. So you'll see that what I've done is actually link this to the video where you can watch them doing the factorizing for you. And I've just written down this example as well. Okay. So the first thing that they do is they also multiply the two together to get 210, and they look for factors that add up to 31 of 210. Okay, so we're just going to go through it quickly. 1 and sign at the back is a plus, so my signs in the brackets are the same, so I can just add my two columns together. Okay, so 1 and 210 does not give me negative 31. 2 and 105, no. 3 and 70, no. 4 is not a factor. 5 and 42, no. 6 and 35, no. 7 and 30, no. 8 and 9 are not factors. Here we go. 10 and 21. Okay, so what we're going to do is we're going to write down, oh, sorry, I shouldn't have actually written in the bracket here. So we're going to write down 3x squared. Then we're going to write down minus 10x minus 21x. Okay, so we're writing down the things that make up. We're splitting the 31 into 2 and then plus 70. And now what we do is we use the method of grouping. So we're going to group these two together and these two together. So here the only thing we can take out is an x. So I'm just going to be left with 3x minus 10. And here I'm going to take out a negative 7. So I'll be left with 3x minus 10. And here we can see our brackets are the same. So our factors in the end are 3x minus 10 and then x minus 7. And we are done. So this is quite a nice one in the fact that you don't have to try and remember to divide by the things. And also it's quite simple. So what I did on the calculators, I just said 3 times 70 over x. I didn't even work out what it was until I saw that number there. So that's quite a nice method for doing it, particularly if you like grouping things. I mean, hey, each to their own, right? Okay. So the last method that I want to show you here is the box method, and it's also a really nice method. I'd actually never seen it until I came across it the other day when I was doing my research for this presentation. If you want to look at a more in-depth set of examples, you can visit the Purple Maths blog. It will show you how to do it. So for this one, the first thing that we need to do is to take out a common factor of -3. So we're going to do that first before we can do any other steps. So we're going to have x squared minus 5x minus 12 there. A better mouse pad. Okay, so should have done this a long time ago. So what we're actually looking at is we're going to do the same thing where we multiply the a and the c together. So we're going to have 2 times 12, and I've done that. You can see I've done that in my table mode. And then, I put the factors in the wrong way order. I'm so sorry. And then again, we're going to look for things that add up to 5 in our middle. So here we're going to have 1 and 24 doesn't make 5. The sign at the back is a minus, sorry. So one column must be a minus and one column must be a plus. So minus 1 plus 24, not what I'm looking for. Minus 2 plus 12 gives me plus 10, no. Minus 3 plus 8 gives me plus 5. So I need to switch my signs around. So plus 3 minus 8 gives me minus 5. Okay. So what we can then do is we're going to draw a box, okay, with 4 things inside. The first thing will be your ax squared. So that's going to be 2x squared here. And then this will be your c value will go at the bottom one. And then we just put the 2 factors or the things into our boxes. So this can be plus 3x and minus 8x. The places that you put them into the boxes over these two don't matter, because when we factorize, you'll see it will come out the same in either way. So I just want to move this so that we can actually do what we need to do. Right, so what we do is we look down the column and we take out a common factor here. So here our common factor is 2x, right? And our common factor over here is 3. Okay, plus 3. Here our common factor is just an x. And here our common factor is a negative, and our sign it's going to be a 4. Right? So our factors here are 2x plus 3. I'm just taking it from the top here. And x minus 4. Right? And those two give me 12. And then, of course, don't forget your highest common factor in the front. So the box method is quite nice as well, in the fact that it's quite straightforward, not difficult, as long as you remember to take all the factors and to look at the signs as well. Okay. Awesome. Everyone happy with this method? Any comments, questions, suggestions? You're all still awake? All right. Now, the last thing that we should do is just to show you how to check your answer on the calculator, because it's kind of a good skill to have. So what I've done is I've actually used the same equation as the previous one, and you'll see I should have actually taken out a common factor. So I'm going to do that first. So 2x squared minus 5x minus 12, right? And then we're going to say equals, 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 equals. And we're going to go look for where our answer is 0. So if we go look there, our answer is 0 when x is equal to 4. So that tells me that my factor is x minus 4, right? Now if I go look, this side is just increasing. So I'm going to go back the other direction and look. Oh dear. So here you can see the minus 2 and the minus 1. Between minus 2 and minus 1 is our 0. Okay, so what we're going to do is we're going to go to our step and we're going to divide it by our a value. So in our example, that is a 2. So we're just going to have 1 over 2, or a fraction basically of a half. And if we now go look, between -1 and 2 is -1.5, and we get our 0. So x is equal to -1.5. And if we took that all back, we would see that it would give us 2x minus 3. Okay, or 2x plus 3, in fact. So that's just to check that we've got the correct x's on the calculator. Just a quick way, very nice and easy. steps to follow. You'll see I actually did the steps here for the 6x. So I made my step 1/6. And you can see again, even though it would take me longer to get there, I still get to -1.5 as my second answer. All right, let's move on to completing the square. Okay, so with completing the square, again, always check out highest common factor first. Okay, make sure that there is nothing in front of your x squared. It must be a 1 in order to complete your square. Okay, so always make sure that your a value is a 1. So divide the rest of your equation by whatever the value in front of the x squared is. Okay, or expression, whatever makes you happy. Well, this is an expression. Then what you do is you are going to add and subtract the value of b divided by 2 squared, right? So I'm just going to say the sign doesn't matter because it's being squared, but we'll just do it anyway. Like so. So that this part here becomes your brackets, and you'll see it just becomes x minus 5/2 squared, and then this will become 25/4 minus 8, and we can use the calculator to solve for that, and that is your tail. Now this will help you when you are doing parabolas in grade 11, when you're looking for your turning point. This is your p value, and this value here will be your q value here. Okay, awesome. So that's completing the square. Then, of course, the next example is your quadratic formula. Okay, so I want to show you, it's a really nice way to do it. So what we're going to do is just go home on the calculator. That just takes us to normal mode. And you're going to just save your A, B, and C values into your calculator. So our A value is 3, so we say 3 stored in A. Our B value is -51. So we store that in B, and our C value is 17. So we store that in C. Then all we would do is type in the quadratic expression or the quadratic equation. So we're going to have -b plus square root b squared minus 4 times a times c over 2a. Right? So that's your quadratic equation. We say equals, it gives us this answer. To find the other x root, okay, the short version, press your left arrow once, okay, to take you back to that expression that we've just typed in. Press second function and left arrow again. That will take you right to the front, and it's much quicker to get to that minus, which we can, the plus, which we can just change for a minus, and then give us our second question, or our second, x value. Now, what's really nice about this is you can store new values into your A and into your B and into your C. And then all you would do is go back up and press equals again, and you can find your x values really quickly again. So if you're doing a whole set of these, this is really a nice shortcut to have on your calculator and to know how to do it. Of course, if you just change the answer, it will give you the actual decimal value of the x intercepts. All right, fantastic. So there's all the steps for you written out nicely. So the last thing that I want to show you is the cubic equation. Okay, and then I promise we are all done. So this is particularly for grade 12. So there are 3 methods, and I'll talk about the last one in a sec. So the first one is to actually use your factor remainder theorem on the calculator. Okay, so what you would do is substitute values into your x until you reached a point where it gives us 0. Now, we were lucky enough to substitute 1 in first and get a 0 straight away. So that might not necessarily always be the case. So the same way we use the K method when we are doing trigonometry, where we have 0, -1, 1, and then we spread it out further from there. We would do the same with this method here. So we always start with 0, 1, -1, because commonly that is a factor. Okay. Once we know that x is equal to 1, we know that x minus 1 is a factor. then we can use the K method to find the rest of the expression. Okay, so what we do is we've got our factor, and then what we say is what times x will give me x cubed, and that's just going to be x squared, right? And what times minus 1 will give me minus 15? Well, that's plus 15, right? Okay. Then from there, we draw a nose and a smiley face. Okay. I like pictures. So a nose and a smiley face is a good way to remember this. And then we multiply the two together. So we're going to have kx squared with my smiley face, and my nose is going to be minus x squared. And it's equal to, and these two here, we're missing these two inner values. Okay, so we found the outer values. So we need to find the inner values. And we use the x squared. So we're going to use the x squared value here. So we're going to have 7x. Okay, now we just have to solve for k. So we know kx squared is equal to 8x squared. So k is equal to 8. Now we can just fill it into our trinomial. So we've got x minus 1, x squared plus 8, x, and then plus 15. Okay, and here again, you can factorize the trinomial. So 15 we know is 3 times 5, and that will give us 8. So here we'll have x plus 3 and x plus 5. And we've got all of our factor pairs. Thanks, Solani, for joining us. I appreciate it. All right, cool. So that's that method. Okay, I like that method. I don't like the dividing with the long. I find it very complicated and confusing. I don't think it's necessary to teach it at all. The other nice way to do it is actually just to do it on the calculator in table mode. So I'm just going to plug in the function to the power of 3, same one that we've used now, x squared plus 7x minus 15, right? And equals. And again, we're looking for our zeros. So x is equal to 1, which means our factor is x minus 1 because we take it across the sign. Here you can see it's just increasing. There's not going to be any zeros, so we go in the opposite direction. Here's my next zero. So x is equal to minus 3. When I take it across, it becomes x plus 3. If I look again, x is equal to minus 5. So when I take it across, it becomes x plus 5 is a factor. And then I found all the factors. And you can see if I continue again, there's no more factors in that direction. It's just dropping off astronomically. The nice thing about the Sharp calculator is your table mode is unlimited. So it makes finding factor pairs really, really easy because you have so much space to look for them as well. Okay. Now, the last way that you can solve a cubic equation is actually to use our W506T. But the W506T is not allowed in the Department of Education for pure math students at all. So you cannot take a W506T or any calculator that has an equation solver in it. It's not allowed. Okay, so in that case, we recommend the W535. And they've done that because it gives certain students an advantage over other students who just don't have that function, because the calculator price difference comes into play. Okay, so I've just done the steps here, and it's quite simple. All you would do is choose the equation solver mode on your W506, so that's by pressing mode 4, then choosing the cubic equation over here, which is 3, and then all you would do is fill in your values for A, B, C, and D. So you're going to have 1, this one's going to be 7, 7, and 15, minus 15. Sorry, that's over there, negative 15. And then you can see again, your roots are minus 5, 1, and minus 3, which is what we came to anyway. So that's just a very quick way to check that your answers are correct. All right. I think I have bombarded you with enough information. Sorry, guys. So just a summary quickly. Highest common factor, always check for that first, even though I didn't in my workshop today. but always do check for your highest common factor first. And then as a general rule, if you count the terms, you should either, when you have two terms, have a difference of squares or a sum and difference of cubes, usually. If you have three terms, it's normally a trinomial, or four terms, it's grouping or a cubic equation if you're in grade 12. But be aware, of course, there are always exceptions. So pay attention to the degree of your expression or equation that you're working with. Remember, trinomials are x squareds, cubics are cubes. And then, of course, if you have grouping, they can be any size. So that's also one of the things to look at. All right, fantastic. Thank you guys for your time. I hope that you found